We're going to look at finding a point of a coordinate when we have slope. So our question reads, a line has a slope of 3 over 4 and a coordinate of negative 3, 7. What is the y value of the coordinate at 5 and the y value being the unknown? Okay, so we know that the x value is 5. So we have 2 points on this line. Let's label them. This will be our first coordinate, so we'll call this x1, y1. And this will be our second coordinate, which we'll call x2, y2. And what we're going to do here is we also have our slope, which is 3 or 4. This is what our m is equal to. Okay, so we're going to plug these in and use our slope formula to actually solve these. So we have our slope formula here. M is equal to y2 minus y1 over x2 minus x1. So, like we said, our m is 3 over 4. So we're going to replace m with 3 over 4. And that will be equal to, our y2 is our unknown value. So we're just going to call that our y. That's what we have in place of it. Subtract our y1, which was 7. Try to color code this as best we can. Our x2 was the value of 5. And our x1 was negative 3, so we're going to be subtracting negative 3. So we'll write the rest in black here to quickly get through this. We have 3 over 4 is equal to y minus 7 over, and this is the equivalent of 5 plus 3. So it becomes over 8. So we get 3 over 4 is equal to y minus 7 over 8. Okay. There's a couple different ways we can go about this. I can bring the 8 over, and we keep it as a fraction. Or what I can do is I can multiply a common multiple of our denominators to get rid of our fractions. So a common multiple of 4 and 8 is actually 8. So I'm going to multiply everything, both sides of the equation, by 8. So I multiply 8 over here. The 8 and the 8 create a 1, and it's also known as being canceled out. When I multiply over here, the 8 divided by 4 create a value of 2. So it's the equivalent of just doing 3 times 2. So we get 6, 3 times 2 is 6, is equal to, and over here everything else canceled out or created a 1, y minus 7. When I bring 7 to the other side, it'll become positive. So 6 plus 7 equals y. Y is 13. Okay, what if, the same formula though, what if these were switched? Okay, so let's do the same idea. It's because it's a little more complicated when we're solving for the x. The x was unknown, and we'll say the y was the value of 5. So set everything else being the same. So our m is still, we'll set it up, m is equal to y2 minus y1 divided by x2 minus x1. Okay, our m we knew was 3 over 4. And in this one, our y2, so this will be our y2 and this will be our x2. Our y2 we have a value for, it's 5. Subtract our y1 is 7. Okay, so we have those numbers. I didn't quite color code them this time. And our x2 is the unknown, so we're just going to write the value of x in for it. And it's going to subtract still the value of negative 3. Again, let's simplify this. We get 3 over 4 is equal to 5 minus 7. And that we can simplify to just be negative 2, right? So negative 2 divided by, and I have x plus 3. Well, we need to isolate for x, and it's on the bottom of a fraction. So you may have seen this before where they tell you to make a let statement. Okay? And really we can move the entire bracket over at once and multiply because this is division. So when it comes over, we would technically multiply. But that might be complicated. So what I'm going to do instead is I'm going to say let the letter a equal x plus 3. So you can kind of see this as a better visual. And we have 3 over 4 is equal to negative 2 over a. And the goal is to get a by itself. Okay, well, to move a over, we need to multiply by a. Okay, and technically we do it to both sides, and on this side it creates a 1 or cancels out, whatever you call it. And we get 3a over 4 is equal to negative 2. Okay, and again I want to kind of get rid of this fraction, so I'm going to move the 4 over also. We know that's just going to be multiplying by 4. So this will become 3a is equal to 4 times negative 2 is negative 8. Okay, but the a wasn't really a. We're going to plug back in. It was technically x plus 3. So we get 3 times x plus 3. So we're going to use our distributive property. And this way we moved more than one value at once. Okay, so if you're able to see that, really what we did is we just took this whole bracket and we multiplied x plus 3 times this 3. And in one of the steps, we moved the 4 over here. But this is essentially, didn't zoom in as well as I like, what we have down here. So we're going to distribute it now. See how this x is a little more complicated. Distribute the 3, and we get 3x plus 9 equals negative 8. We move the 9 over, it becomes negative, so 3x is equal to negative 17. And we need to move the 3 over, so we divide. So x is equal to negative 17 over 3, okay? Which is a little under 6, a little under negative 6. So that's how we use our formulas to find our missing